This is section 511. We're going to be defining a polynomial. So we're going to verify if a function is a polynomial and describe the degree, the leading coefficient, etc. of a polynomial. Now, three of the families of functions that we've studied so far, we've looked at a constant, which is a horizontal line, a linear function, which is just any line in any direction. We looked at quadratics, has that parabola shape, and they belong to a much larger group of functions called polynomials. So a polynomial is almost like an umbrella term, and amongst these polynomials, we have the quadratic and the linear, the constant. If you guys remember that parent function, the cubic, right, that had that shape, that was also a polynomial. All of those are part of the polynomials. Now, a polynomial function is a function of this form. Now, I know it's kind of weird to interpret this statement here, but let's kind of go through it. All I'm saying is these values in front, we call those coefficients, and they have to be real numbers. That's it. So 5, 7.2, 1/2. So these values that are in front, the constant and what it's in front, they just have to be real numbers. Can't have any imaginary numbers. The second piece to it is your degree will be counting down. So whatever this number is, it starts at the highest and then it counts down by 1, by 2, by 3, by 4, and then 2, 1, and then nothing, right? So they count down. Those degrees has to be greater than or equal to 1, and it has to be a natural number. So can't be 1.5, can't be the square root, can't have any of that type of stuff. Now there are many elements about this definition that can be frightening. The best thing is to look at an example. So if I have 4x to the 5th minus 3x squared plus 2x minus 5, guess what? This is a polynomial. Now I can rewrite it in this form, right? Here's my, if I were to compare this to this definition, 4 is my a sub n. X to the 5th, that 5, that's going to be my n. Now, I don't have an x to the 4th, but I could write it as plus 0x to the 4th. So 0 is that next value, 5 minus 1, right? N minus 1, 5 minus 1 is 4. I don't have an x to the 3rd, so 0 again, x to the 3rd, subtract 1 again. Then I have my negative 3x squared. See, I subtracted 1 again, right? So all I'm doing is the degrees are going to count down. 5, 4, 3, 2, 1, nothing. And then we just look at the numbers in front. You just do that, you put it together, it's going to be a polynomial. So let's look at a bunch of different examples, and this is where we just got to be careful because, you know, some of these are polynomials and some of these aren't. So this first one here, the 4x to the 4 plus x to the 3rd, if I were to divide that out, I get x to the 3rd over x plus 4 over x. It's not a polynomial, mostly because the domain of a polynomial is negative infinity to positive infinity. I have a domain restriction here, so it's not going to work out. But this also, I can't have an x in the denominator like that. Same thing with part B, right? That x going to both of them, it's not going to work out. It's not going to be a polynomial. Now for C, is this going to be a polynomial? Well, if I were to break this up again, x to the 3rd over x squared plus 4, 4x over x squared plus 4. Again, like this whole dividing thing, I can't have more x's in the denominator. It doesn't work that way. So it's also not a polynomial. Now this cube root of x, right? This is x to the 1/3. We said the exponents can't be fractions. They have to be natural numbers. So that's also not a polynomial. And in that definition, did we mention anything about absolute values being in there? No. So it's also not a polynomial. And then the last is this constant. Are constants polynomial? Yes, we said that it's one of the family of polynomials. Now, a few terms that are important that we do need to get down. The degree is n. It's the highest exponent in your polynomial. The leading term is this value in front of that x to the n power. We call that our leading term. So whatever has the highest power, the number in front, we call that our leading term. And then that's together, right? Both of those are together. The leading coefficient, that's the number that's going to be in front. And then the constant is just the number that's going to be by itself. Now we need to know what these 4 pieces of information are, because we're going to use those 4 pieces of information throughout this entire process. Now, if it's just a constant, the degree is going to be 0. Right? That's a number other than 0. If it's 0, it's actually going to have no degree at all. So let's just kind of look at these. My degree, what's my highest exponent? 5. My leading term, 4x to the 5th. My leading coefficient, what's that number in front? 4. What's my constant? The number by itself, -5. Pretty straightforward. My degree, so we're looking at that. That's going to be x to the 3rd. The leading term, okay, that's that entire thing. Sorry, my degree is 3. That's going to be x to the 3rd. The leading coefficient, the number in front. So there's a 1 in front, so it's going to be 1. And then the constant, there's no number, so there's technically just a 0, because there's no number by itself without an x. So if I were to break this up, this is going to give me minus x over 5 plus 4 over 5. So my degree, well, this is x to the 1st power. My leading term is going to be negative x over 5. My leading coefficient, now if I were to break this up further, I could look at that as negative 1/5 x, so that's going to be negative 1/5. The constant, just the number without an x associated with it, that's going to be 4 over 5. Now this next one is going to require us to be just a little tricky, or at least a little, we have to focus a little bit of understanding on the way that exponents work. Now for part D, I just want you to know that we are going to be able to find the information that we're going to need from it, the degree, leading term, and all that different stuff. We're going to focus that just a teeny bit later on in class. And we're going to use this factored form to be able to pull that information. I just kind of wanted to show you that we can do it. It's possible, but we're going to use that at a later time. So what did we learn today? We talked about polynomials and the degree of the polynomial, what the polynomial looks like, verifying if something is a polynomial or not. Now the constant is the value that doesn't have any x next to it. And then the leading coefficient is the value in front of the term that's my leading term, or the in your polynomial, right? If you look at your degree, that's the highest exponent. It's the number in front of whatever has the degree. This does conclude our lesson. If you have any other questions, please leave them in the comments.